Hello everyone, welcome to DS class. In today class, I am going to explain the next type of queue, that is priority queue. Earlier we have seen the ordinary queue, then circular queue, and then third type double-ended queue. And today it will be of fourth type of queue, that is priority queue. Uh, what is the difference between above three types and this type? In above three types of queue, we are going to insert the element in either from the rear end or from the uh, front end, or you can delete the element from the front end or from the rear end, like in the double-ended queue. In this one, we are going to insert the element based on the priority, or you can say we can insert the element or remove the element from any position based on the priority. Okay. And this type of technique used in the job scheduling algorithm, like an operating system where the job with the highest priority have to be processed first. Okay. And in this if I'm going to insert the new element at a particular position, that element will be considered as an highest priority element. Okay. And in this queue we always store the element in the increasing order. So we insert the element into queue in such a way that they are always in the increasing order, such that highest priority with the lowest value at the rear end, and lowest priority with the highest value at the front end. Like in this example I have taken here. Initially the 10 will be having least element. We're inserting from the rear end, so initially the 10 will be the least element but having highest priority. So once it will reach to the 0th position, like we start from 0th position only, so this will be the having the least element with highest priority. Okay. And then now I am going to insert the element 60. This 60 will be inserted in the increasing order after 40. So this will be considered an highest priority item will be inserted at particular position. Okay. In order to implement this, uh, we are taking an loop called insert an item, where item we are inserting q will be an size, and star r I have taken as an, it is an address where rear is available, and that value will be assigned to the j. Why I am taking j is that I am going to insert this 60 after 40. In order to keep track of the location, I make use of the j variable. Okay. Then what is the queue size here? Queue size is 6. 0 to 5 it becomes 6. Then if star r, or you can say the pointer r which holds the address of the rear pointer, is equal to queue size minus 1. Queue size is 6. 6 minus 1, 5. That time the queue is full. But in this example the queue is not full because I have taken only 5 element. The queue size is of 6 element. Then in this example the queue is not full. As I told, j contain the address of rear. So address of rear pointing at which position? The position is 4. Now j will be holding at the position 4. Then while j greater than equal to 0, j value is 4, 4 greater than equal to 0, condition true. Then item less than equal to, item less than q of j. What is the item I have taken? Item I have taken 60. 60 less than q of j. Q of j is q of 4. Q of 4 is 70. 60 less than 70. Both the conditions are satisfied. That is 4 greater than 0, true. Similarly 60 less than 70, true. If it is both the conditions are true, then get inside the loop. Q of j plus 1. J value is 4. 4 plus 1 is 5. So j of 5, now we come at this place. J of 5 equal to q of 4. So 70 will be shifted to the next bit. Earlier q of j is 70. It will transfer to where? Q of j plus 1. Now 70 will come at fifth position as I shown in the next table. It will come at fifth position. Then j minus minus. So j will again bring back to the previous value. At that place q of j is 3 now. Then q of j plus 1. Q of 3 plus 1 is 4. At 4 insert the item. Q of 4 is 0, 1, 2, 3, 4. Q of 4 is 60. Now you are inserting 60 at the new position of J. Then again we have to make use of getting the address of the rear pointer. Increase the rear pointer to the next bit because that previous value will be occupied by the item 60. Again we have to reposition the new rear value. Okay, this is how the priority uh, queue operates. Like we are going to insert the new item. That item will be uh, stored in a particular location, that too in a increasing order. Like here 60 will be stored at fourth location, that is following the increasing order condition. Then we are going to shift the earlier value to the next position. In that position I am going to insert the 60. In order to perform that, we make use of this loop. Okay, these all things we have studied in the second module. Like in the first chapter, it is based on stack. Then second chapter based on the recursion, and this third chapter based on queue. In the beginning queue, we have seen how to insert an element into the queue, like by using ordinary queue. Then similarly, the disadvantages of an ordinary queue is that whenever we have deleted some element from the front end, even though the positions are free at the beginning, but we can't insert the element. Okay, in order to overcome that problem, we go for circular queue. Then in the next type of queue is double-ended queue. In that queue, we are inserted the element from both the end, like from the rear also, from the front also, we can insert the element. Similarly, we can delete the element from the both the end. Okay, in that we have 5 operations. Out of that, 3 operations already covered in the ordinary queue, and remaining 2 operations I explained in the previous video. Then in the above those queues, we are inserting and deleting the operation will be performed sequentially. But in the priority queue, where you want to insert the element, you can insert based on the some criteria, like it should be in a increasing order. Okay, shifting the values, then in that place insert the element. Then the next bit is the dynamic memory allocation. As I told in the previous chapter, when we go for dynamic memory allocation is that whenever the memory is full, that time we are going to insert into element. That time we can resize the value by making use of reallocation. Then we can insert the element. For that, I have taken an example in the push operation. Whenever the in the stack, whenever the stack is full, whenever it reaches to q size -1, it is not possible to add the element. But if we go for dynamic memory allocation, by using realloc function, we can increase the size and we can add the new element. Similarly, in the queue also, we can increase the size by using realloc function, and we can insert the new element. Okay, this is how the second module get completes. In the next video, I am going to start with the third module based on the linked list. Thank you. And if you have any queries in the introduction class, I am going to uh, cover it, clear all the doubts.